A very important part of dealing with quadratics is factoring. You should have learned it in Algebra 1, but let's review because some kids come in with it a little bit weak, and it's an incredibly important skill that we'll use not just in quadratics, but in other things. So first, what is factoring? Well, factoring means to rewrite as a product, which is the answer to a multiplication. So we want to rewrite something as a product. For instance, in elementary school, we learned how to factor something like 6, and it means to rewrite it as a multiplication. So how can we rewrite 6 as a multiplication? Well, it's 2 times 3. So 2 times 3 is 6, and this is factored. The product will always equal the original one. They're the same thing, just written differently. We could also factor something like 10. If we factor the number 10, it's 2 times 5. This is factoring because we have rewritten it as a product. In algebra, we learned that we could factor in a number of different ways, and we could take all these algebra expressions and factor them. And of course, what that means is rewriting them as a product. The first idea is before we get into factoring, let's make sure we feel comfortable about how to multiply things in algebra so that we can feel comfortable writing things as a multiplication. How do we multiply something like 5x times 3x plus 7? Well, I hope we know that if there is something, this is a binomial because of this plus, and when we have, this is a monomial, even there's a 5 and an x, there's no adding or subtracting here, so this is a single term, but this is a binomial, which means bi means 2. There are 2 terms adding or subtracting together, and when you have something adding or subtracting, multiplying times something that's multiplying, the thing on the outside multiplies times both of them. So 5x times 3x, when you multiply 5x times 3x, we multiply the coefficients, and we get 15. And we multiply x times x, and x times x is x squared. So that's the first thing, 5x times 3x. And then we get 5x times 7, and we're going to add these because it needs to be adding. 5x times 7 is 35x. 5x times 7 is 35x. And this is our answer. Similarly, we could distribute a negative. This is considered like it's like a -1 that's multiplying it, and the negative will distribute across this binomial as well. The negative of x squared is negative x squared. The negative of positive 5 is negative 5. And we can even distribute something like a half. Notice this is a trinomial. There's 1, 2, 3 terms being separated by pluses or minuses. The 1/2 will multiply times all of them. This is how distributing works. 1/2 times x squared is just 1/2 x squared. Half of 4 is 2, so half of 4x is 2x. Half of 10 is 5. So another way to think of multiplying by a half is dividing by 2. So 4x divided by 2 is 2x. 10 divided by 2 is 5. So hopefully we feel good about how to multiply. We can use that idea of how to multiply to go backwards. This is not multiplying right now, but when we factor, we can rewrite it as a multiplication. That's our goal always. And one way of doing it is by using the GCF, or greatest common factor, GCF. Common means they all have it. Greatest means using the biggest one of them, and factor is something that can multiply to make them. So when we look at these, we're looking for something that can multiply to make all of them. What is the number? And what we'll always do is we'll first start by looking at the coefficient. The coefficients. So 3 and 12, we're going to ignore the variable for now. Is there a number that can multiply to make both 3 and 12? And the answer is yes. 3 is 3 times 1. 12 is 3 times 4. And if they have a common factor, then what we can do is, it's called factoring out the greatest common factor. And we take whatever the greatest common factor is, in this case 3, they both have a 3. And we're going to put it outside of the parentheses because we can use this idea of distributing to say, look, if they had something that they both had in common, that's the thing that's outside of the parentheses, that's the GCF, and it can multiply times 2 things to make this. 3 times x will give us the 3x. 3 times what will give us 12? Well, we need a plus 4 here to actually make it distribute. 3 times x is 3x, and 3 times 4 is 12. And notice this is factored because we now have things multiplying. 3 is multiplying times x plus 4. 3 is one of the factors, and x plus 4 is the other factor, and it's done. Sometimes they also have a variable in common. So we're going to look at the greatest common factor. To look at the greatest common factor, we're going to start with the coefficients. 5 times 1 is 5. 5 times 6 is 30. So they both have a 5, and I'm going to pull that outside of the parentheses. But they also both have an x. Now, they don't both have an x squared. They only both have an x. X squared is x times x, and x is just x, and so they both have an x. It's always the lowest exponent thing is what they have in common. In this case, they both just have an x in common. So this is our greatest common factor, and it's the reverse of what we were doing here. We're bringing something to the outside. The 5x is going to be on the outside, and the question is, what is the binomial that it needs to multiply by? And so I always just think 5x times what will give me 5x squared? Well, 5x times x will give me 5x squared, and 5x times what will give me negative 30x? Well, a positive has to be times a negative to give a negative, and 5 times 6 is negative. 5 times negative 6 is negative 30, and it already has the x, so we don't need an x here. Another way you can think about this, of course, is that if you take the 5x out, you can think of it as each of these as being divided by 5x. So 5x squared divided by 5x is just an x. Negative 30x divided by 5x is negative 6. Another way to think about it. Now, these don't have anything in common. However, it is considered not fully factored if there is a negative in front. And so whenever there's a leading negative, we will factor out the negative. So they don't have, like an 11 and a 1 don't have anything in common. This is considered a 1 in front. And they don't both have an x. So the only thing they can be factored out is a negative. So a negative of what will give you negative x squared? Well, it's just negative of x squared. And negative of what will give us positive 11? Well, if we put a positive 11 here, it would be negative of positive 11, which would be negative 11. That's wrong. We need to switch the signs. So when we factor out a negative, negative of x squared is negative x squared. Negative of negative 11 is positive 11. And when we factor out a negative, it will just switch the signs of everything on the inside so that when you multiply by the negative, it will give you the right answer. We also use this when we have a fraction in front. We never like dealing with fractions, and so whenever there's a fraction, especially in the front, but it could be anywhere in here, we can factor that fraction outside. And so we'll say like, okay, half of what gives us 1/2 x squared? Well, half of x squared. Half of what gives us 8x? And if you can't see it, remember we're dividing by 1/2, and dividing by 1/2 is the same as multiplying by the reciprocal, 2 over 1, which is 2. So these can all get if we factor out the 1/2, we're going to multiply all of these by 2. And this will be 16x, and this will be 4. And you can see that that will work. Half of 16x is 8x, half of 4 is 2. You could have just thought half of what will give you the right thing. So hopefully you're feeling good about using the GCF. The other type of factoring we'll do is factoring trinomials. X squared plus 10x plus 24. These don't have anything in common. These both have an x, but not this one. These both have a 2, but not this one. So they do not have a greatest common factor. And let's go back to our understanding how multiplying works to feel good about this. When we multiply two binomials times each other, the way it works, these are two binomials because there's a plus here and a plus here. The first term in the first binomial will multiply times both of the other two terms. Then the second term in the binomial will multiply times the other two terms. So let's start. X is going to multiply times both of these. X times x is x squared. X times 10 is 10x. Then the 3 is going to multiply times both of these. 3 times x is 3x. 3 times 10 is 30. And we'll notice that we have two like terms. X squared can't add with this. They aren't the same kind of term. You can't add these together. But 10x's and 3x's can be added together to give me 13x. And what we'll notice is that when we're trying to go backwards, there is a way to rewrite this as a product. Remember, factoring just means rewriting it as a multiplication. X plus 3 was multiplying times x plus 10 at the beginning. And so when we have something like this, we can rewrite it as a multiplication. Let's see how. Well, the first thing we should notice is that it's when there's a trinomial, tri means 3. So there's 1, 2, 3 things like this, starting with an x squared. We'll notice that it's going to need to be a binomial times a binomial. when you multiply it out, it'll come out right. So to get the x squared, we'll always start with x times x. That way when it distributes, it will give me the x squared. We also notice that these two numbers, when they multiply out, these will be two constants. When you do a constant times a constant, it's going to give you 24. And so we need two numbers that multiply to make 24. But I don't know if you noticed this, but when we multiplied this out, we got 3x's and 10x's, and they ended up adding together to be 13x's. This middle term with the x's came from adding these two together. And so this middle term we'll need to add to make. And a lot of times we'll write it like with an x, and we'll say, look, we need to find two numbers that multiply to make 24, but add to be 10. And what two numbers are those? If you have trouble doing this, the easiest way to think about it is what are all the different ways to multiply to make 24? So I start with 1, like 1 times 24, 2 times 12, 3, I just go 1, 2, 3, 3 times 8, 4 times 6. And I'm looking for two of these that add to be 10. In this case, 4 and 6 add to be 10. 4 times 6 is 24. 4 plus 6 is 10. And so that's going to be the other part of each of these binomials, this 4 and the 6. X plus 4, x plus 6. When this multiplies out, so these multiply together to give this. X times x will give you the x squared. 4 times 6 will give you the 24. And when you multiply it out, you'll get 4x's plus 6x's, and that will add to be the 10x's. So we're looking for what two numbers multiply to make the constant and add to be the number of x's. Why don't you try it with this one? Well, in this case, we are multiplying to make x squared. So x times x gives you the x squared. And now we need two constants that will multiply to make negative 20, but add to be, this is a negative 1. So start with, I like to just ignore the negatives for just a second and just think of 20. What are the ways to multiply to make 20? Well, there's 1 times 10, 1 times 20, 2 times 10, 3 times nothing gives me 20, so I'm going to skip it and do 4 times 5, which is 20. Now I'm looking for a way to make negative 1 here. These won't make negative 1, these won't make negative 1, but I notice 4 minus 5 is negative 1. So the question is, one of these needs to be positive and one needs to be negative, because a positive times a negative will give me a negative. The question is which. And since they need to add to be a negative, the bigger one needs to be negative. I need it to be a negative 5 and a positive 4. That way when I add negative 5 plus positive 4, there's still negatives left over. Negative 5 plus positive 4 is negative 1. And so this is my answer. It's going to be x minus 5 times x plus 4. It would be completely fine if I wrote x plus 4 times x minus 5. Things can multiply in either order. A times b is the same as b times a. You can multiply backwards if you want. Both of these are considered correct. Okay. One more to try. So let's see how you do. We need two things that multiply to make x squared, so x times x. We need two things to multiply to make the constant, so they multiply to make 16, and they add to be negative 10. Start with the ways to multiply to make 16. 1 times 16, 2 times 8, 4 times 4, and I need something that'll make negative 10 here. 1 and 16 won't combine to make 10. 4 and 4 won't combine to make 10, but 2 and 8 will. Now, if I just did 2 times 8, that would be 16, but 2 plus 8 would be positive 10. I can also multiply to make a positive by doing a negative times a negative, and that's what has to happen here. It's negative 2 times negative 8. A negative times a negative gives me a positive, but negative 2 plus negative 8 is positive 10. So negative 2 and negative 8, or I could have done negative 8 and negative 2. Both are fine. So hopefully you're feeling pretty good about that. The last is a special thing. Now, we could do this as a trinomial. We could think of this as x squared plus 0 x's minus 100. And you can think of it as being a trinomial with a middle term of 0. So it multiplies to make negative 100. That adds to be 0. But here it's helpful to think of how you're going to add to be 0. The only way to add to be 0, so it's still got to multiply x times x to get you the x squared. The only way to multiply to make 0 is if it's a positive something and a negative of the same thing. So maybe positive a and negative a. So it has to be the same exact number, but one positive and one negative to add to be 0. So you can just do the square root of 100. So what times what gives you 100 that's the same number? Well, 10. Positive 10 and negative 10. This will multiply to make negative 100 and add to be 0. Whenever you see the difference of two squares, it's the square root of this one. So square root of x squared is x, plus the square root of this one times the square root of this one minus. So it's the difference of two squares. If you have a squared minus b squared, it will be a minus b times a plus b. You'll do the square root of this one, and it goes in both places. You do the square root of this one and goes in both places, but one has to be positive and one has to be negative. That way, when you add them together, you get 0. So try it with this one. What is, and this one's harder, right? What is the difference of two squares here? How do we factor this? Well, hopefully we see this as 3x times 3x. It's a square number. So 3x and 3x. And this one's a square number also, and it's the difference. So minus 5 and plus 5. And we're done. Like, that's it. The difference of two squares is always you do the square root of the first one minus the square root of the second one, and then the square root of the first one plus the square root of the second one. I'd like to note that if you have a squared plus b squared, this is prime, which means it can't be factored. So the difference of two squares can be split up into a multiplication, but never the sum of two squares. So that's it for factoring. Hopefully you feel pretty good about it. We're going to use it a lot this year.